Giving everyone another minute or so to log in. Answering some emails from students that had actual questions about their work, which is great. I'm going to pause this timer, otherwise it makes quite a racket when it actually finishes. Okay, so I had a request from another student. I'll let you guys help me find it. Let's see if there's an example to one she's asking for. This is weird, looking at myself. Yes, that's really similar to the one she had. Hang on. So the timestamp on this would be right about almost 18 minutes. Now I feel like I'm just talking to myself. About the 18-minute mark. Okay. Copy. Bum, bum, bum. Let me get rid of you. Okay. Time to get to it. So, goals today. Let's see. Well, we want to be discussing equations with variables on both sides, equations with parentheses, numbers of solutions to an equation. Okay. Great. Now, I don't have any emails with any screenshots of any particular problems. So I guess I will just start plucking ones that we can work on, starting with this guy. Bring it on over. All right, so we're trying to solve for h with variables on both sides of the equation. Here we go. So get my math practice standards out. So let's start off by just making sense of our problem. Okay, so we need to solve for h. Check. Okay. In this case, we are going to be doing some abstract reasoning. And the abstract reasoning that we're going to be doing the most for our inverse operations will be stuff. The two we've used the absolute most are always going to be that anything plus its opposite is going to be equal to 0, and then anything divided by itself is equal to 1. So those are our abstract reasonings that we're going to be using a lot. So first step on your own paper is just to write this equation down again. So go ahead and write down on your own paper 17 minus, oh, that's a plus 4h plus 2 equals 1 minus 5h. 17 plus 4h plus 2 equals 1 minus 5h. Yeah, always make sure you wrote it down correctly. Please always make sure you write it down correctly. So the first thing we want to look for are like terms that can be combined. For instance, this 17 and this 2 are on the same side of the equation, and they are both constants, meaning they don't have any variables attached to them. So we can go ahead and add those together. So positive 17, positive 2. So we'll end up with 4H. Let me back my color. So we still have 4H. But instead of plus 17 and plus 2, let's just go ahead and make that plus 19. That's equal to 1 minus 5H. Okay, so now this is where your intuition has to kick in. No one's going to tell you what to do. You just have to understand, okay, well, if I want to get H's by themselves, I need to get all the H's on the one side. And because I prefer to have positive values, I'm going to go ahead and I'm going to add 5H to both sides. The reason I'm doing this is this abstract rule that we were talking about down here, because 5H plus its negative 5H makes a 0. That cancels out in the vernacular of us math teachers. And that's not the only thing we're going to try to cancel out. We want to get the H's on one side, and we want all the constants to be on the other side of the equation. That's all the whole numbers or decimals or fractions, things that don't have variables. So the opposite of adding 19 is adding a negative 19. So I'm going to do that to both sides. Now 19 minus 19 is 0. So what do we end up with in our next next line here? Well, 4H plus 5H, that's 9H. Plus 0 equals, now 1 minus 19 is negative 18. And then negative 5H and 5H makes 0 again. So here's where we're left with. 9H equals negative 18. So again, your intuition has to kick in and figure out, okay, well, how do I get H by itself? Well, the opposite of multiplying by 9 is dividing by 9. So I'm going to do that to both sides. And the whole reason I did that is this abstract rule, because anything divided by itself is equal to 1. So 9 divided by 9 is equal to 1. Therefore, I'll end up with 1H. And negative 18 divided by 9 is negative 2. So what we just figured out in this particular system is that when you do all this inverse math, that H has to be equal to negative 2. And just to go back to our practice standards, we modeled our math. I constructed a viable argument to prove that I'm right. I guess we could prove that actually, I guess to get credit for that check mark, I would probably have to go back and put a negative 2 here and here, which would make 17. 4 times the negative 2 is minus 8. Plus 2 equals 1. 5 times the negative 2 would be negative 10. So negative, the opposite of that would be plus 10. So both sides should come out to be 11. So 17 minus 8 is 9. 9 plus 2 is 11. 1 plus 10 is 11. So that balances out. Okay. So I get credit for constructing the viable argument. I attended to precision because I was very careful with all my numbers. We reasoned abstractly already. I don't know, sometimes I think making use of structure is just making use of this step-by-step procedure. That's what I like to think of structure as. And I'm not really sure appropriate tools. Maybe I'll leave that one off. But yeah, so there's the first problem out of the way. Variables on both sides of an equation. Let's try another one and see if you guys can get it before I do. I think we said this would be negative 2. Huzzah. Okay, chat. Time to work. So we are given this equation, and it's your job to figure out what B is equal to. So if I had to just give you little reminders, combine like terms, use inverse operations, get all the B on one side. Get all constants on the other side. And then solve for B. Okay, let's see if you can pull that off without much assistance. I'm looking for answers in chat. You can do it public or private. Let's see what you get. While I pull up a spreadsheet. Okay, I've got one answer from chat. Give you guys another few seconds to see if you can sort it out. Okay, so let's see. Move this down here for a bit. All right, so combining like terms. Well, first, I guess I should write down the equation. That usually does help. So 4b plus 5 equals 1 plus 5b. Yeah, combining like terms, really there's nothing that can be combined because on the left side of the equation, there's a variable and then a constant, and then the right side of the equation, there's a variable and a constant. Nothing really mixes yet. So I've got to move on. So can't really do that. Inverse operations to get b on one side and then get all the constants on one side. Okay. So I like things that stay positive, and I know if I subtract 5b from both sides, I'll end up with negative b's. So I'm going to go ahead and I'm going to take away 4b from both sides. That doesn't mean if you subtracted 5b from both sides that you end up with the wrong answer. We should all end up with the right answer. I just try to engineer it in a way where I always end up with positive values if possible. So I'll take away 4b from this side as well. Then on the left side, let's see, how can we get rid of these constants? I want to get the constants over because, okay. Since these are going to cancel out, I'm going to get the constants over to that side. So to do that, I'm going to take away 1 from both sides. So what we end up with, so 4b minus 4b is 0. 5 minus 1 is 4. 1 minus 1 is 0. And 5b minus 4b is 1b. Oh, and we're kind of incidentally just done. Normally we might have extra work to do, but not today. So b just comes out to be 4. And if you had done it any other way, you still should have ended up with that answer. I guess if I could rewind my thinking. if you had subtracted 5b from both sides, you would have ended up with negative b equals, hang on, I gotta move that because I'm about to end up under our pictures. Okay, for anyone that just was gung-ho about subtracting 5b from both sides, you would have ended up with negative, negative b, because 4b minus 5b would be negative b, and you'd have subtracted 5 from both sides, and 1 minus 5 would have been negative 4. So if you ended up with that, you'd end up just, you can either multiply or divide both sides by negative 1. Either one, you'd end up with b equals 4. So we still all end up with the same answer. All right, one more, then we're moving on to other stuff. All right, same challenge. Here it is. There's your equation. Without any tips or tricks, let's see how far you can get without needing assistance. I want you to solve for r. Let's just see what you can do when you're not tipped in the right direction at all. Go, 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 go. For you wondering what I'm looking at, I am updating my spreadsheet. We got to keep track of students that have been contacted during the week, be it by Google Classroom or Remind or Zoom or email or anything. And if you don't stay on top of that, it becomes too much to do on like a Friday. All right, we'll go back to that in a minute. So no answers yet? Chat, nothing? Okay, well, I can work it out. Let's start by rewriting the equation for ourselves, shall we? 16 minus 2r equals negative 3r plus 6r plus 1. 16 minus 2r equals negative 3r plus 6r plus 1. Okay. Now I'm going to combine some like terms because I can. You might notice on the right side of the equation, I've got negative 3r and 6r. And they both have the same variable to the same power. So the 16, can't do anything with it yet. The negative 2r is just going to have to wait. But negative 3r plus 6r is the same as 6r minus 3r. So those two things make 3r, and I still have this plus 1 stuck onto it. All right, you both, okay, so everyone in chat got the same answer. Let's see if I agree with you. Okay. So now, let's do some inverse operations. So if I want everything to stay positive, I'm going to add 2r to both sides. Because if I were to take away 3r, I'd end up with negative 5r, and who wants to do negatives? If I can avoid it, I will engineer it to do that. But if I'm moving, so, okay. So in my mind powers, if I am canceling these two things out, moving all the r's to the right side, that means what I probably want to do is take away 1 from both sides and shift all my constants to the left side. So these go bye-bye. And what we end up with, so 16 minus 1 is 7. I almost said 17. 16 minus 1 is definitely 15. Plus 0, because these canceled. 3r plus 2r is 5r. And then 1 plus -1 is 0 again. So now my next move is to divide both sides by 5. 5 divided by 5 is 1. 15 divided by 5 is going to be 3 is equal to 1r. So yes, chat, you are correct. Everyone that answered did get this one correct. I agree with you. The answer is definitely 3. Let's move on to something completely different. Welcome 9FGZKY. And they left. Maybe they're fixing their names so we can actually call them by something. Okay, so this time we're gonna be, okay, so the directions are basically the same, solve for F, but in this case, before you can get to all the maneuvers we just did, they need you to do some work with parentheses. So this is really the exact same lesson with one extra step added at the beginning. So I was gonna, if I was to rewrite our little equation here, which is -11 F equals 7 parentheses 1 minus 2F n parentheses plus 5. Okay, so the first thing I notice about this is that I have this distributed property where I've got a 7 being multiplied by a binomial. So what you do is you multiply the 7 times both the first term and the second term. So this is sort of the extra step added on to what we were just doing. So the -11F just has to wait a second. 7 times 1 is 7. 7 times a -2F would be a -14F. And then we still have this plus 5 on the end. Now, once we've done that, what you're staring at is just like the last lesson we just did. So all they did was add on the parentheses step. So in this case, I'm going to combine my terms. I have a 7 and a positive 5. So I still have -11F on this side of the equation. Nothing's changed for that guy. But 7 plus 5 is 12. So that'd be the same as having 12 here minus 14F. Okay, so we've combined our like terms. Now we need to start moving these things around with our abstract rules. So what if we just added 14F onto both sides, because I like having positive things. So -11F plus 14F would be -11, I think it's going to be 3F. And then, of course, we are done with these two because they cancel each other out. -14F plus 14F is nothing. So 3F equals 12. Last thing, if we just divide the left side by 3 and the right side by 3, 3 divided by 3 is 1. So 12 divided by 3, so F would equal 4, or it should be. Yeah, okay. So these are the exact same skills really as the last lesson, with one small step introduced at the beginning, which is the distributive property moment, where you have this term outside of parentheses and you've got to multiply it by whatever's on the inside. So you guys try this one. All right, so here's your equation. Give you a minute of a head start while I check my documents. And let's see if you can solve for f correctly. Attend to your precision. Let me get my math practice standards on screen. There they are. Ah. I think we've already made sense. Okay, so I guess what I should harp on, what I should be really trying to press here, is that you should be looking for an express regularity in repeated reasoning, meaning like take what we just did in the previous few problems and apply that here, because if it worked back then, it should work now. Make sure you attend to precision. I think we've already made sense of the problem. Just persevere in solving it. We're to use abstract reasoning for sure whenever we do inverse mathematics. Go, 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 go. Okay. I don't see any answers yet in chat, so I'm going to try and catch up to you real quick. The first thing I'm going to do is I'm going to multiply this 3 by both terms on the inside of this parentheses. That's the distributive property. So what I end up would be, I'd end up with 18 minus 3f. And please chime in on chat if you're like, well, hey, where'd that negative 3 come from? Something like that. So 18 minus 3f minus 4 equals 3f minus 4, because that right side hadn't been touched yet. Okay, so the next thing I see I can do, I can combine this 18 with this negative 4. They're on the same side of the equation. Neither one of them has a variable. That means they're both constants. Well, 18 minus 4 is 14. So 14 minus 3f equals, and I still haven't done anything to the right side, 3f minus 4. Okay. So then the next inverse math, and this is just intuition that has to kick in. If I were to add 3f to both sides, and if I were to add 4 both sides, good things are going to happen. So by adding 3f to both sides, these make it 0, and all my variables be on the right side of the equation. And by adding 4 to both sides, this makes it 0, and all my constants will be on the left side of the equation. So that should make for easy going. So 14 plus 4 is 18. Negative 3f plus 3f is 0. 3f plus 3f is 6f. Negative 4 plus 4 is 0, so 18 equals 6f. Okay. So then to get f by itself, I'm just going to divide by 6 on both sides. Well, let me change color. Okay, so 6 divided by 6 is 1, so that'd be just 1f. Eighteen divided by 6 is 3. So I'm pretty sure in this system, f is always going to be equal to 3. Yep, we're all right. Sweet. Feels good to be smart. Okay. What else? Let's try something different. Ah, yes, the numbers of solutions. Okay, so before we really get into this, I'm going to do a real quick refresher. So, how many solutions does the following equation have? Okay, when it says solutions, what it means is sort of like if you were picturing lines on a graph, sometimes lines intersect once. So, okay, so let's do a really thorough explanation. So, no solutions. When you have two lines that are parallel to each other, they never touch. They don't have any solutions. When you have two lines, I should do a different color for this. Hang on. But sometimes you'll have two lines that intersect once. So that's what it means by one solution. One solution is the spot where they connect. Okay. Now, infinite solutions, this one's going to be a little difficult to draw, actually. Ooh, I can draw lines with arrows on them. Saves me the time. Sweet. Okay. So, infinite solutions. Oh, much better visual. So, infinite solutions is when you have two lines that are exactly on top of each other because they are always going to have the exact same answers. So that's the visual version of no solutions, one solution, and infinite solutions. Okay. But we're not graphing these at the moment. So what are we talking about when it comes to sort of like an equation version of these things? Okay. So no solutions, when we work this out, we'll end up with something to the effect of like 8 equals 17, which is just false. So that's our signal that there were no solutions. Now, exactly one solution is where our work will end up with something like y equals 9. We have one answer, so that works. Now, the infinite solutions, the signal for that, what's going to tip us off is when we get something like, oh, I don't know, 14 equals 14. Where it's always true. So those are going to be our three signals we're looking for. So we're about to work this equation out, and we're going to find it's going to be one of these three things. We'll either get some sort of an answer where two numbers just are not equal to each other, which means it's false. We'll get exactly one answer where y equals number, x equals numbers, d equals number, whatever the variable is. Or the infinite solutions would be where we get a whole number equals the exact same whole number, like something that's just always true. So let's see which one we end up with. So I take y, 7. 7 parentheses y plus 3 n parentheses equals 5y plus 8. 7y plus 3, 5. Okay. So the next thing, and this should be something you should be like, hey, we just did this. Distributed property is the first thing I got to do. So that'd be 7 times y and 7 times 3, both terms. So I end up with 7y plus 21 equals 5y plus 8. Okay, so then I can take away 5y from both sides. And I can take away 21 from both sides. That cancels, that cancels. So 7y minus 5y is 2y plus 0 equals 0. And then positive 8 minus 21 would be negative 13. Okay, so once you get used to these, you would have realized a few steps ago what the answer is, but we'll go ahead and just keep working this out. Now we'll divide both sides by 2, and I don't care if it's this really weird mixed number negative fraction. The fact that we come down to y equals anything, I mean, it does not matter how ugly that is. It can be a decimal, fraction, negative, improper, mixed, whatever. If it comes out to y equals something, then what we just discovered is that there is exactly one solution. Even though it's a weird, ugly fraction, it still means there's one solution. Let's try this one. I want you guys to take a stab at it without much help from me, and then I'll educate you if you have questions. And just as a reminder, no solutions, you'll get something like 4 equals 10, something that is just never true. Exact solutions, you'll get z equals a number like, I don't know, 12. I'm not saying it has to exactly be 12, just z equals number. And then infinite solutions would be something just like 9 equals 9. These are just examples. They're not exactly. Let me put a little thought bubble. Drawing clouds is fun. Okay. So go ahead. Rewrite. Yikes, that was a horrible line. Okay. So rewrite this equation. Solve for z by doing all the inverse operations and all the combining like terms you know how to do. And let's just see if it comes out to be no solution, exactly one solution, or an infinite number of solutions. So I'll give you a minute. Go ahead and get started, chat. We'll see how it goes. Okay, so let's see how insightful we all were with this one. Okay, so the first thing I'm going to notice, you know, I'll go ahead and I'll type it out. Okay, so 60z plus 50 minus 97z equals negative 37z plus 49. The quicker you get with these, the faster you'll realize what the answers are without even doing much scrap work. So if you're bothered by these big numbers, then just get better at them and you'll have less to do. Oh, let's see. 60z plus 50 minus 97z equals negative 37z plus 40. I always double check that I wrote down the numbers right. So combining like terms, right here, I've got a 60z and a negative 97z. They both have the same variable, same power. So 60 minus 97 will be a negative 37z. So that's going to be negative 37z plus 50 equals negative 37z plus 49. Uh-oh. And this is where my intuition is beeping, and I already know what the answer is. A, B, or C, that is. 37, I'm sorry, negative 37 plus 50 equals negative 37. Okay, let me rephrase. Negative 37z plus 50 is equal to negative 37z plus 49. I'm almost positive we just found a no solution, but we can prove that with some inverse operations. So like, let's say you were to add 37z onto both sides of the equation. So then this makes a 0 and this makes a 0. So what you end up with is 50 equals 49. And that is not true. So this is one where there'd be no solution because it comes out to something that is just false. I think we get time for a few more. So looking at this one, what do you guys think? No solution, exactly one solution, or infinite solutions? I'll give you a couple seconds to start. See how you do. Oops, I've been muted for the past couple minutes. Sorry. I guess you have to learn to read lips, or I don't know. I don't know. Sorry about that. Okay, so let me rephrase for this one. 19x plus rx equals negative 37x plus w. There's an x, an r, and a w. Oh, goodness. They're not asking you to come out with an answer here, like a number. These problems are designed to punish you if you use calculators too much, because you're allowing the calculator to do too much thinking, and you're not building enough rigor in yourself to understand the laws of these equations. So they give you stuff like this. So we're going to solve for x, but I'm going to tell you now that the answer is going to have unknown variables in it. There'll be w's and r's, and it's just going to basically, we're going to take this garage sale pile and move everything to one side. And so it's just x equals blah. That's what our goal is. So let's start by writing it down on our own paper. So 19x plus rx equals negative 37. That's it. Negative 37 x plus w. 19x plus rx equals negative 37x plus w. Okay. So, goodness gracious. Okay. So the first thing we want to do is get all the x's onto one side. Oh, this is going to be a trip. You guys are going to see me do this and be like, oh man, do we really have to learn how to do that? Yes, you do. So we're going to add 37x to both sides. And I'm going to leave the rest alone. I think I should move that over. Hang on. No, you stay there. Okay. So if I add 37x to both sides, 19x plus 37x will be 56x. Plus rx. Now, negative 37x plus 37x makes 0. So this is all equal to w. Now, we're going to do the opposite of a distributive property. The distributive property is when you're multiplying a term into a binomial or a trinomial or whatever. This is where we're going to be ripping something out of a binomial. It's called factoring. So you'll notice that both 56x and rx are both multiplied by x. Therefore, I could rewrite this as x times 56 plus r. And that's the worst w in the history of w's. Okay, so that little maneuver, there's an x on both. So we're going to rip it out. We're basically dividing both of these terms by x. But what we're left with is x times this binomial of 56 plus r. And that is something you can get very good at with very small amounts of practice. So now, again, we want to get x by itself. So right now, x is being multiplied by this big binomial. So if we just divide by that binomial, 56 plus r, on both sides, as gross as it looks, according to our abstract rules, if you divide by the same thing, you multiply, that makes 1. So what you end up with is that x equals w over 56 plus r. Now there's a chance when I go to type this in, it's not going to like it. It might prefer, and this is just a maybe, we'll see. It might prefer this to be x equals w over r plus 56. Now those are the same thing because all I did was use the commutative property to rearrange the addition. but technically speaking, variables should come first. So let's just see what it says. So I need to make this into a up and down fraction. So that'd be W, no, not two, W on the top. And let's just try the first way. Let's just try 56 plus R and see what it says. Oh, it took it. Whoa. So we're right up against an hour. This lesson bothers students. They get the twitch or it's like, I need an answer. Well, this is the answer. It just happens to have lots of variables in it. So this is the one that really is a real workout and stress of your inverse operation skills and your understanding of what's going on, because you can't just plug this into a calculator and have it spit out an answer. Oh, it's 7. Nope, it's not going to happen. But what I'm encouraging everyone to do is to get their quizzes done, because it gets you, Khan will give you 2 chances to get your quizzes completed with a high grade level. If you come across a question on your first attempt of a quiz, screenshot it, send it to me. We'll talk about it so you can do better on the second attempt. Grades are due by Friday. I mean, your assignments are due by Friday. Well, I was hoping everyone would have had their first attempt done by today at 3 p.m. But that brings us to an hour. It's been fun. I love doing me some math with you guys. I hope more would attend the live sessions and bring me work that they need help with, bring me some screenshots. But take care of yourselves, take care of your family. Make your beds. Every good day begins with a made bed. And I'll see you guys next time.